Hi, I'm Natalie, and I'll be presenting on hypoparathyroidism. So, earlier in the semester, me and Miranda had done an interview with a rare disease patient, Jen, who suffers from hypoparathyroidism, as do another 70,000 people in the United States. And it is the result of the symptoms of a lack of parathyroid hormone, which parathyroid hormone is responsible for keeping a sufficient amount of calcium in the blood, and calcium causes your muscles to be able to contract and your nerves to be able to fire. So parathyroid hormone is very important, and this can be caused by either a lack of parathyroid hormone or an inability of the kidneys and bones to respond to parathyroid hormone. Symptoms can include hypocalcemia, tingling in the hands, elevated serum phosphorus levels, fatigue, cramping, and tetany. And both low and high calcium levels can cause organ failure and death. So commonly, it is caused by surgical removal of the thyroid, like a botched surgery that takes the parathyroid glands as well, because they're located right on top of the thyroid, which is what happened in Jen's case. She explained to us that she has a autoimmune disorder that caused her to need to have a thyroid surgery. And like 15 years ago, she ended up with hypoparathyroidism and has been living with it since. Though many other people do have hypoparathyroidism because they have a birth defect. Rarely, people are born without parathyroid glands, but more commonly, people are born with a disorder or a genetic mutation that results in them not having the ability to make parathyroid hormone.
On the thyroid is the parathyroid glands. Parathyroid cells contain calcium-sensing receptors, which sense the plasma calcium levels and release parathyroid hormone in its absence. PTH travels through the body to release calcium ions. PTH receptors on osteoblasts sense the increased levels of PTH and induce the release of the RANK ligand, which binds to its receptor RANK on osteoclast precursor cells. This leads to activation and formation of osteoclasts, and calcium and phosphate ions from bones are released. An excess of PTH can cause bone loss. PTH stimulation in kidney cells increases reabsorption of calcium and conversion of vitamin D to a usable form, which increases absorption of calcium in the intestine. In hypoparathyroidism, there is often no parathyroid hormone, which leaves no mechanism to increase calcium levels, or some instances are mutations causing malfunction to the calcium sensing receptors, so PTH is not released at all. On the thyroid.
So that was an animation that I made, and music is my friend Alex and I. So the molecular biology of hypoparathyroidism. So the calcium sensing receptors on parathyroid cells are what can tell that there's not enough calcium in the plasma and would ordinarily release parathyroid hormone into the body to then recruit the osteocytes and osteoclasts for calcium and phosphate from the bones. And parathyroid hormone leads to bone formation, and that it binds to osteoblasts, which release the RANK ligand to go to the osteoclast precursor cells and turn them into mature and active osteoclasts. And this, in the process, releases calcium and phosphorus into the system, and the calcium goes to the intestines to help the body absorb it again, and also just into the blood to continue to the rest of the system. So primary literature article about a deletion in the 22q11.2 deletion syndrome, which causes an immune deficiency for many patients. So congenitally, many people are born with DiGeorge syndrome, which is a deletion on chromosome 22. And when it includes the TBX1 gene deletion is when they've found people to have immune deficiencies as well. So there was an immunologic evaluation of 52 infants around the age of 1. One of the groups had a TBX1 deletion within the 22nd chromosome. Another one of the groups had a separate 22q11.2 deletion that did not include a deletion of the TBX1. And then the final group had a duplication in the 22nd chromosome that included a duplication in TBX1. And what was found, as you can see in the figure, A is referring to the CD3 cell count, B is referring to the CD4 cell count. And for both of these, they found significantly lower levels of TBX of CD4 and CD3 cells where there was the TBX1 deletion. They found no differences between all three of the groups for the CD8, CD19, and natural killer cell counts. This led them to conclude that TBX1 deletions contribute to a weakened immune function in patients with DeGeorge syndrome. So hypoparathyroidism often is treated by supplements of calcium, vitamin D, which helps the body absorb more calcium and helps the body absorb phosphorus and keep the phosphorus levels low enough. And people often take magnesium supplements as well. And when people, while taking treatment, still have too low of calcium levels, they might take a thiazide diuretic, which helps the body to secrete less of the calcium through urine. Many people were able to take synthetic parathyroid hormone, which is under the brand Natpara, but currently it has been recalled by the FDA because, well, Jen was speaking to us in the interview about this, that it was a intravenous dosage that was given over a 2-week period, and the way that the rubber stopper in the lid of it was with the hypodermic needle meant that rubber particulates could potentially get into the drug. So since last September, there has not been a form of synthetic parathyroid hormone on the market. And Jen was saying that it was very life-changing for her to be part of some experimental medicine at the NIH in Bethesda, partaking in the experiments for this drug to be approved in the first place. So currently, there are no synthetic parathyroid hormones on the market that are FDA approved. All solutions relating to that are involved in experimental medicine at the moment. But people do often cater their diet to be very rich in calcium, which would mean a lot of leafy greens and a lot of dairy products, and low in phosphorus, which means avoiding soda, hard cheeses, and meats. There has been some gene therapy research on the horizon pertaining to hypoparathyroidism, which was a mice study where human parathyroid hormone gene was inserted into a murine stem cell virus, and these recombinant retroviruses were used to infect a line of murine hematopoietic stem cells, and then these stem cells were grown and injected into mice that were suffering from hypoparathyroidism. And they found that the serum levels of calcium and parathyroid hormone were then normal in these mice for another 3 months after. So they effectively were able to cure hypoparathyroidism in mice, though this study was also done in 2005. So it still may be a while, but gene therapy is on the horizon as well. So thank you for watching.